Right now, a spacecraft launched before you were born is racing through the darkness, 25 billion miles from Earth, farther than any human creation has ever traveled. But here's what will blow your mind. It would take this probe 73,000 years to reach our nearest star. We're going to journey beyond the edge of everything we know, explore ships that ride nuclear explosions, meet civilizations that harvest entire stars, and discover why the universe itself might have an expiration date. Make sure to hit that like button and subscribe, because what we're about to uncover will change how you see our place in the cosmos. Prepare yourselves. We begin. Picture yourself standing at the shore of an ocean that stretches beyond every horizon you can imagine. You think our solar system ends at Pluto, but you're wrong. Way beyond that distant ice ball, there's a region called the helipause where our sun's influence finally dies. This invisible border sits about 11 billion miles from home. So far that light from the sun takes 16 hours just to reach it. If you drove a car at highway speed without stopping, the trip would take you 12 million years. Think of our solar system like a giant soap bubble floating in space. The sun blows this bubble with something called solar wind, a stream of charged particles racing outward at over 1 million mph. For billions of miles, this wind pushes against the emptiness, creating a protective shield around everything we know. But eventually, even the sun's mighty breath grows weak. At the helipause, our solar bubble meets the fierce winds of interstellar space. Here, alien particles from distant stars crash into our cosmic neighborhood like waves against a sea wall. The temperature drops to nearly absolute zero. The very atoms that make up space itself change. You've left the influence of the only star humanity has ever known. Voyager 1 crossed this boundary in 2012, becoming the first human-made object to enter true interstellar space. Its radio signals now take over 21 hours to reach Earth, longer than an entire day. The probe sends back whispers from a realm so foreign that our best scientists are still trying to understand what it means. But here's what should make your head spin. This edge, this boundary that took us 35 years to reach with our fastest spacecraft, represents less than 110,000th of the distance to our nearest neighbor star. Imagine taking a single step on a journey that would circle the Earth 2.5 million times. That's how far we've come compared to how far we need to go. The helipause isn't just a border, it's a warning. Beyond this point, the rules change completely. The gentle warmth of our sun becomes meaningless. The magnetic fields that protect us from deadly radiation vanish. Even time itself behaves differently when you're moving between the stars at impossible speeds. Standing at this cosmic shore, you realize that leaving our solar system isn't just about building faster rockets or better technology. It's about becoming something entirely new. A species capable of surviving in the vast, cold darkness between worlds. But our first visitors to this strange realm have already begun sending back the secrets we need. Next, we follow humanity's most daring ambassadors into the unknown. 2 golden records spin through the void, carrying the sounds of Earth to civilizations we may never meet. Launched in 1977, Voyager 1 and 2 were supposed to explore Jupiter and Saturn, then quietly fade into space. Instead, they became humanity's first interstellar ambassadors, racing toward distant stars with messages from a blue world they'll never see again. Each probe carries a golden record containing the sounds of whales singing, babies crying, and music from every corner of Earth, a cosmic message in a bottle. Voyager 1 travels at 38,000 miles per hour, faster than any spacecraft in history. At this speed, you could fly from New York to Los Angeles in 4 minutes. Yet, after 46 years of flying, it has barely begun its journey to the stars. The probe won't come within spitting distance of another star for 40,000 years. Think of these spacecraft like medieval ships, setting sail for unknown continents. Their captains knew they might never return, but they carried the hopes and dreams of everyone they left behind. Voyager's computers have less processing power than your phone. Yet, They continue to function in conditions that would destroy any earthly machine in seconds. The cold out there doesn't just freeze things. It changes the very atoms that make up the spacecraft. Metal becomes brittle as glass. Electronics that worked perfectly for decades begin to fail in ways engineers never predicted. The probes are slowly dying, their nuclear hearts growing weaker with each passing year. But these dying messengers have already revolutionized our understanding of what lies beyond. They've detected magnetic fields twisted into impossible shapes by stellar winds. They've measured cosmic rays from galaxy, destroying explosions that happened before Earth even existed. Most shocking of all, they've discovered that interstellar space isn't empty. It's filled with a thin soup of hydrogen atoms and mysterious particles from the birth of the universe. Every day, Voyager's radio signals grow weaker. By 2025, the probes will fall silent forever. Their nuclear power finally exhausted. They'll become ghost ships sailing through an ocean of stars, carrying our golden records to destinations we can only dream about. Scientists estimate that in about 300 million years, long after humans have either evolved into something unrecognizable or vanished entirely, one of these records might be found by an alien civilization. They'll hear our music, our languages, our laughter. They'll learn that once on a small blue planet, there lived a species crazy enough to throw bottles into the cosmic ocean. But Voyager taught us something even more important than what's out there. It showed us that we can build machines tough enough to survive the journey between stars. The real question isn't whether we can reach other solar systems. It's whether we can survive long enough to get there. And that brings us to the most terrifying discovery of all. Between here and our nearest neighbor lies a darkness, so complete it makes the deepest ocean trench look bright as day. Space isn't just empty. It's aggressively, violently empty in ways that human minds struggle to grasp. If you scaled down our solar system until Earth was the size of a marble, the nearest star would sit 1,400 meters away. That's like placing a marble in New York and expecting to hit another marble in Denver with a perfect throw. But the emptiness goes deeper than distance. In the best vacuum chambers on Earth, scientists can remove almost all the air, leaving about 10 million particles per interstellar space. There's less than one atom per mass between stars into a volume smaller than a grain of sand. Think of it like this. Imagine trying to swim across an ocean where the water is so thin you can't even feel it. So cold it would freeze your blood in seconds, and so filled with invisible radiation that it would cook your DNA from the inside out. That's what spacecraft faced in the void between stars. This emptiness plays tricks with physics itself. Without air to carry sound, the universe becomes permanently silent. Without matter to conduct heat, temperatures hover just above absolute zero, minus 450 degrees F. At these temperatures, even helium becomes solid. Metal shatters like glass. Electronics die for reasons scientists are still trying to understand. The radiation out there makes Chernobyl look like a health spa. Cosmic rays, particles accelerated by dying stars and black holes, slam into anything in their path at nearly the speed of light. A single cosmic ray carries more energy than a baseball thrown at 60 miles per hour, concentrated into a space smaller than an atom. These invisible bullets would shred human DNA, causing cancer, brain damage, and death within months. Even worse, the magnetic field that protects us on Earth disappears completely in interstellar space. Solar wind from distant stars creates electromagnetic storms that could fry any electronics we send out there. Imagine trying to use your phone during a lightning storm that lasts for centuries. But perhaps the most unsettling discovery is that this emptiness isn't uniform. Space between stars contains clouds of hydrogen gas, cosmic dust, and mysterious dark matter that we can detect but not understand. These clouds can stretch for hundreds of light years, creating invisible walls that could damage or destroy anything moving through them at high speed. Flying through interstellar space at the speeds we'd need to reach other stars would be like driving through a sandstorm at 200 millionth. Every speck of dust becomes a bullet. Every gas cloud becomes a wall of destruction. Yet somehow in this hostile void, we've detected something that changes everything about how we think about space travel. Our next destination makes this emptiness look crowded. 4.4 light years away burns a star so dim you need a telescope just to see it. Yet, it holds the key to humanity's survival. Proxima Centauri is our nearest stellar neighbor, a red dwarf star barely 1/8 the size of our Sun. If our Sun is a roaring bonfire, Proxima is a dying candle flickering in the cosmic wind. This tiny star produces so little light that its potentially habitable planet receives only 1% of the energy Earth gets. But here's what makes your spine tingle. That planet Proxima b sits in the Goldilocks zone where liquid water can exist. It's just 4.25 light years away, practically next door in cosmic terms. At the speed of our fastest spacecraft, the journey would take only 73,000 years. For an immortal species, that's practically a weekend trip. Think of Proxima Centauri like a lighthouse on a distant shore. You can see its beacon. You know exactly where it is, but the ocean between you and safety is filled with storms that could destroy any ship you build. The star itself weighs only 12% as much as our Sun. Yet, it unleashes solar flares that make our worst space weather look gentle. These stellar tantrums release more energy in minutes than humanity has produced in all of recorded history. The flares bombard Proxima b with radiation levels that would sterilize the surface and strip away any atmosphere. If life exists there, it would need to hide deep underground or develop shielding that makes our best technology look like paper armor. Red dwarf stars like Proxima live for trillions of years, hundreds of times longer than our Sun will survive. While our solar system dies in 5 billion years, Proxima Centauri will still be burning when the universe itself grows cold and dark. It's the ultimate long-term destination for a species planning to outlive the death of stars. But the journey to reach it represents the greatest challenge humans have ever faced. Moving at 10% the speed of light, faster than anything we've ever built, would still take 43 years. An entire human lifetime spent crossing the void between worlds. Babies born on the ship would grow old and die without ever seeing their destination. The energy required to reach such speeds defies imagination. You'd need to convert matter directly into energy using Einstein's famous equation. The fuel alone would weigh more than entire mountains. Even if we solved the energy problem, the cosmic radiation during decades of flight would be lethal to any human crew. Yet scientists have already detected dozens of potentially habitable planets around red dwarf stars within 50 light years of Earth. These ancient suns offer humanity something our own star cannot: time. Billions of years to evolve, explore, and spread across the galaxy before the last stars burn out. Proxima Centauri isn't just our nearest neighbor. It's our cosmic life insurance policy. But reaching it requires us to break the most fundamental speed limit in the universe. And that's where Einstein's rules turn everything upside down. Nothing with mass can ever reach the speed of light, and that one fact might doom humanity to die on a single world. Einstein discovered that as you approach light speed, something impossible happens. Your mass increases toward infinity. To push even a single atom to light speed would require all the energy in the universe. It's not just difficult, it's mathematically impossible, written into the very fabric of reality, like a cosmic speed limit enforced by the laws of physics themselves. Light travels at 671 million f. At this speed, you could circle Earth 7.5 times in 1 second. You could reach the moon in 1.3 seconds. You could cross our entire solar system in 11 hours. Yet, even at this incredible velocity, reaching Proxima Centauri would take 4.25 years. Think of the speed of light like the ultimate highway speed limit. Except the penalty for trying to brake, it isn't the ticket. It's the complete destruction of physics as we know it. As spacecraft approach light speed, time itself begins to slow down relative to the rest of the universe. at 99% light speed. 1 year on your ship equals 7 years on Earth. This creates what scientists call the time dilation paradox. A crew traveling to Proxima Centauri at near light speed might experience only a few months of flight time, while everyone they left behind ages decades. They return to find their friends and family dead, their civilization transformed beyond recognition. They become time travelers trapped in a future they never chose. But the energy requirements make even this scenario impossible with current technology. To accelerate a spacecraft weighing as much as the space shuttle to just 10% of light speed would require the energy output of the entire United States for over 100 years. Getting to 90% light speed would demand more energy than our sun produces in a century. Even if we solve the energy problem, relativistic effects turn space dust into cosmic bullets. At near light speeds, a grain of sand hits with the force of a nuclear weapon. The thin gas between stars becomes a wall of radiation that would vaporize any known material. The universe itself becomes hostile to high-speed travel. Yet Einstein's equations also revealed something extraordinary. While nothing can travel faster than light through space, space itself can expand faster than light. The universe has been doing exactly this since the Big Bang. During cosmic inflation, regions of space separated faster than light could travel between them. This loophole in Einstein's laws opens a door to something that sounds like pure science fiction. We might not need to travel faster than light if we can convince space itself to move us. Instead of pushing through the cosmic speed limit, we could ride the expansion of spacetime itself.